Ms. Talhami. So today our goal is to be able to recognize similar triangles. And we first need to go over what it means to be similar, if you forgot. The symbol was like this, okay? So that's the symbol for two things being similar. It almost looks like the congruent symbol, if you notice, but without the equal sign. So what is the definition or an explanation of what similar is? It means that we are the same shape, but a different size. So what that means is that the shape has gotten bigger or smaller. If you remember what transformation makes a shape bigger or smaller, that's a dilation. Okay, so here's an example of, similar shapes. So here's a square that was enlarged. Those are similar, same shape, different size. Here's a right triangle that was made smaller. Okay, same shape, different size. Now, specific things about them have to be true. Just like when we have congruent triangles, we need 3 pieces of evidence. You still need to have 3 pieces of evidence. But let me talk about the properties of similar triangles before we get started. There are 2 main things you need to know. You need to know one thing about their corresponding angles. And you need to know something different about the corresponding sides. So now what's important for you to recognize is when we had congruent triangles, everything about them was the same. They had congruent angles and congruent sides. But when you have similar shapes, take a look at this square. Here's a 90-degree angle. When I made it bigger, I did not change that it was a 90-degree angle. So notice the angles of similar triangles. If you want to put these, if you have this printed, you might want to change the markings. Notice the angles of similar triangles are congruent. That's one property that you need to know about similar triangles, is that the corresponding angles are congruent. So that means angle A to angle E, angle B to angle G, and angle C to angle F. So that's the first thing you need to know. The second thing now, notice, are the sides congruent? Are they the same in length, the corresponding sides? They are not. So we say that the corresponding sides are in proportion. Or I like to say in the same ratio. Now, what does that mean? One second. What that means is that whatever it's been enlarged by, so let's say, like, remember when we did dilations, everything was multiplied by 2? That means here, if this side to this side was doubled, that means this side to this side is also doubled, and this side to this side is also doubled. So that would mean, like, if this was 3, this would have to be 6. If this is 5, this would have to be 10. And if this is 8, that means this would have to be 16. So that everything is at a 1-to-2 ratio in this example. So in order to do that, we like to write a proportion. So AC over EF, because those two correspond, is equal to BC over GF, because those two correspond, which is also equal to AB over GE or EG, if I wanted to use corresponding parts. Okay, so that's what it means that the corresponding sides are in proportion. I could set up a proportion, which usually you set up only 2 of those, cross multiply and solve to find some missing parts, which is what we'll do tomorrow. But really, that's the main thing you need to know about similar triangles. So if I want to write a statement here, I would write that triangle ABC is similar to triangle EGF. Notice how I didn't go in alphabetical order. I went in corresponding order. A, B, C to E, G, F. Okay, so really that's what you need to know, the two properties about similar triangles that you need to know. So how many methods are there to prove triangles are similar? There are 3 methods. And again, in this example or in this section, you always need to have 3 pieces of evidence, or 3 things. 3 things, just to remind you. So the first method to prove triangles are similar is angle, angle, angle. So now with angle, 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 you need to prove that there are 3 pairs of corresponding angles. Congruent. So 3 pairs of corresponding angles congruent. Let's see if I can fit that on one line just to make this neat. 3 pairs of corresponding angles congruent. I think I can fit it. Okay. So in 2 triangles, that would look something like this. Now, this is the only time I will tell you that you are allowed to do this, is sometimes you don't have to find the 3rd angle. Now, when is that? That's when I know 2 angles are congruent in a triangle, since they have to add up to 180. So a side note, if they have to add up to 180, I know that the 3rd angle for both triangles would have to be equal. So take a look at this. I'll give you a quick side note. So here are 2 triangles. If I know that this is 10 and this is 50, and this is 10 and this is 50, then I already know that these 2 triangles are similar by angle, angle, angle. I already know that this 3rd angle is going to be congruent, because if the angles of a triangle have to add up to 180, and I've already used up 60, that means this angle has to be 120, and same thing in the other triangle, it has to be 120. So that's why sometimes you'll see that instead of angle, 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 this is the only time that you can just have 2 pieces of evidence, which is just 2 angles, because the 3rd is already then known. The next method to prove triangles similar is called side-side-side similarity. So now the reason why we have to put that symbol and call it side-side-side similarity, okay, is because we already use side-side-side when we prove triangles congruent. So we have to address here, I'm not trying to prove them congruent by side-side-side. I'm trying to prove them similar by side-side-side similarity. It's almost like having a class with 2 students that have the same name. If I have John D versus John A, I would make sure to address which one I'm talking to. So if I'm talking with John D, I might use his initial. If I'm talking with John A, I would use his initial. So if I'm trying to say 2 triangles are congruent, I'd only use side-side-side. If I want to say they're similar, I would say side-side-side similarity. Now, what would that look like? There are no markings for this. What that would look like, and I'll actually draw both triangles here so we can discuss what it would look like. I'm going to just do a specific example. I just want to try something out for you. So, and I'm doing some random numbers here right now. So now, why would this be side-side-side similarity? You have to actually show that the 3 sides are in the same ratio. So to do that, I actually have to do the math. Now, it doesn't matter which one you choose first, but you just have to make sure you write it in the same order. So if I'm going to do small triangle over big triangle, then I need to consistently write all 3 ratios where the small triangle number is on top and the big triangle is on bottom. So for example, the smallest number here is a 3. That should correspond with the 4.5. So 3 over 4.5 is how much? So when I put in the calculator, I get 0.6666 repeating. Okay, trying the next pair of corresponding sides. The next biggest number here is a 5. The next biggest number here is a 7.5. So if I do 5 over 7.5, then I get 0.6666 repeating as well. So far it might be similar. And then if I try the last pair of corresponding sides, so I have to do, here I have 8 corresponds with 12. So I have to do 8 divided by 12. And 8 divided by 12 will give me 0.6666 repeating as well. So notice how all 3 sides are in the same ratio or are in proportion. That's kind of the key thing that I was trying to, connection that I was trying to get you here to understand. So since they gave me the same number every time, then these are similar. Now, could you have done this and this and this? Absolutely. Either way, I mean, it would have given you a different number, but that number would have been consistent all the way through. Am I able, though, to choose this and this and this and jump around? No. You have to stay consistent. If you're going to put the, smaller triangles number on top and the bigger on bottom, that should be consistent all the way through. So that's the second method to prove triangles are similar. And then the last method is side angle side. Oh, we've used that with congruency, so we have to say similarity. So side angle side similarity. And what does that look like? It looks very similar to the previous one. So if I take a look here with these 2 triangles, and then here I have, now some of you might be able to look at this and recognize it right away. I'm going to tell you we'll use the smaller number first. So here's the smaller number for both triangles. And now I'm actually going to switch it up. Let me do big triangle over small triangle, just so you can see the difference. So let me do 6 over 2, and I should get 3. And then let me do 12 over 4, because those are the larger numbers. 12 over 4 is also 3. So if you notice, the sides are in the same ratio, and now this is the important part, there is an angle between those similar sides. So since the sides are in the same ratio and they have an angle that's congruent because it's both 90 degrees between them, then that means these are also similar. So these are your 3 methods to prove triangles are similar. If you need to pause it and take some notes, please do so. So let's move on to some examples. So, I want you to just take a look at these. Some of these have some funny looking symbols. They have like little circles like that. Those are supposed to be like arc marks. See, like that. But, the computer was having a hard time. Boxes like that are supposed to be arrows for parallel lines. See, you have that here too. These are supposed to be parallel. So this is a whole, page of examples that if you want to skip the top part, feel free. So we could just do part 2 together. So if you want to pause it here, and if you want to try it out, and then unpause the video, I'll have all the answers for you and the way in which you would do it. Okay, so you could see, oh, something just happened there. Sorry about that. So you could see the answers here. And what you can tell is that I actually had to do a lot of work for some of them. Or not a lot, but I had to do a little work. So with this first one, some of you might have said, hey, these are not similar because they don't have the same angles. But triangles add up to 180. So if you find the third angle for both triangles, you'd say, hey, wait, all 3 of their angles are the same. With number 2, I have parallel lines. So I did that Z. If you remember, that Z is called alternate interior angles. So that allowed me to find many angles. That allowed me to find these alternate interior angles and these alternate interior angles. And then I also have these vertical angles. So that's actually angle, angle, angle right there. For letter C, notice these two triangles are overlapping each other. So I put an X at T because they share that angle. It's a reflexive angle. But yet that's not enough information. For D, I had to check all three ratios to see that they are that the corresponding sides are in the same ratio or proportional. So there's the work that I did for that. For E, I recognized that I had isosceles triangles, so I found the remaining angles of the triangle knowing that. And if you did that, you can get angle, 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 or you could recognize that it's side, angle, side, because if they have two congruent sides here and two congruent sides here, that means the ratio from this side to this side should be the same as this side to this side, which makes this statement a little bit hard to write because it could either be written as SRT or STR when you're talking about it corresponding to triangle CDB. Then if you look at F, we have parallel lines. Notice I did one pair of parallel lines this way, make a Z. And then another pair of parallel lines this way made another Z. So I actually had two angles in each triangle. Now if you remember, we said two angles are enough because then we could just say the third angle is congruent as well. And then here is G. Now G was a little challenging because to find this missing side of this right triangle, I had to do Pythagorean theorem. And I got that this side ended up being 8. So then when I checked the ratios, which I did right here, I got the ratios are the same, 1/2. So you could write them as a fraction or as a decimal. So that's why these are similar by side, angle, side similarity. Now, could you have done Pythagorean theorem here? Find the third side and find out that all three of them and get side, side, side similarity? Sure. And then here's the last example. They only gave you these two angles, which is one angle in each triangle. But you had to catch that this angle right up here was a reflexive because it's shared between both triangles. Now, if these triangles are ever on top of each other or connected with each other, you're always more than welcome to try and draw them separately so that you could see what they share. So hopefully now you could recognize two triangles that are similar and their methods as to why they're similar. If you have even any questions, please let me know. Have a great day, everybody.